Hello everyone, and welcome to what's essentially a bonus lecture for this second week. I wanted to introduce, first of all, the VC mini project, which is about classes. So dealing with one of the topics from the lecture this week. And also share with you some resources for practicing your programming skills outside of the course material. So first of all, if you have caught up with lecture this week, then you may want to start working on the VC mini project. So VC here stands for vector class, because the goal of this mini project is to write a class capable of handling some simple vector algebra in 2 dimensions. And we're calling this a point class because a point in the xy plane is essentially a 2-dimensional vector. So the way that the mini project is structured is we give you a skeleton of a point class. There's your init and your repr method, not yet implemented. So you'll need to replace the init and the repr method with appropriate code for answering the question. And then in each subsequent question, we ask you to add functionality to the point class in order to solve the problem. So in this add-subtract exercise, you should be implementing the plus and minus operators using the dunder methods add and sub. So you would not only have your code from exercise 1, but you would define new methods, add, and of course I add a point object to some other object, a point object actually, and this would be new code. And then the next question, again, I would just copy this point definition to here, and this question's about multiplication. So I would add the dunder mul method. And now this would be code from exercise 2, as would this. So for those questions, the first 4 questions, you just need to update the class definition and then run the grader.score cell. Each grader.score cell has a function defined which you should not change that will be handed to the grader. And if your point class is defined correctly, then this function will answer the question. So all you need to do for the first 4 exercises is just fill in the code for the point class. So for example, this grader.score cell has a lambda function here. We won't change that at all, but what we will do is say create a x attribute and a y attribute. And then we'll update the repr method to use the x and y attributes to print out point x comma y according to the format given in the question. And then once we do that, this function will answer the question at for the grader. So even already we could define the point class like this, and when we run the grader, as long as we import it, then we get a grade back. We got a 0 because the repr method currently just returns 0.00 instead of x comma y, But if we were to change this to at least put in, well, this actually still won't successfully answer any question, but if we had x comma y instead of x comma 0, this would then become a 1. So that gets you started on the first question. It's fairly easy to add the code from here to handle y as well as x. And then you'll carry on in that fashion for the remainder of the project. Question 5 is a little bit different. We ask you to define a new class, cluster, and fill in some code in this compute result function. In the instructions, we describe what these functions and classes should do. You're implementing what's called the k-means clustering algorithm. And we give you very detailed instructions here for implementing that algorithm. And if you fill in the code and send the compute result function to the grader, then you'll get your score back. So that's the VC mini project, and you should start working on that in addition to IP, which hopefully you're already working on. With that discussed, I wanted to share with you a resource outside of the course materials for practicing programming. There is a website called Hackerrank. I'm going to go ahead and log in. Let's see. So if you create an account on this website, you can challenge yourself with their coding challenges. Their coding challenges are categorized by language and topic. So they have a Python domain, and there's many different coding challenges. You can select by difficulty or by topic. So if you're interested in, for instance, challenges related to classes, we could do the dealing with complex numbers challenge. So why don't we do that one, since we've been talking about classes? And it gives you some instructions. This is sort of like a question on a mini project, except Hackerrank is going to evaluate your code instead of the grader evaluating some solution. So it tells us we're given two complex numbers, and we have to print the result of their addition, subtraction, multiplication, division, and modulus operations. It tells us the input format, the real and imaginary part of a number separated by a space, and then it tells us the output format. We should give the results of these calculations on separate lines. And it even gives us sample input and sample output. So we have the complex numbers 2 plus I and 5 plus 6I. So their addition is 7 plus 7I. Subtracting one from the other gives us minus 3 minus 5I, and so on. In this challenge, they also provide us with some skeleton code for instance, for reading in the input as well as printing the output. Not every challenge gives us this, but this one does. And then it's our job in this challenge to just fill in the class definition. So based on what we learned in the lectures on classes, we know that a complex number should have a real and imaginary part as attributes. And so the init method will take the real and imaginary parts as arguments, and we'll create attributes equal to those values. For add, we're going to be adding together two complex numbers. So we know that number here is also going to be a complex number, so we can interact with it the same way as the object we're defining right now. So we want to return here the results of adding together two complex numbers, which is a new complex number with a real part equal to self.real plus the other number.real, and an imaginary part equal to the sum of their imaginary parts. So addition, is an operation that gives us a new number as a result. And the same for subtraction. But we'll have the difference between the real parts and the imaginary parts. So I just see I have a typo here. I'll replace that with imaginary. Multiplication, this is a little bit tricky. If you're unfamiliar with the multiplication of complex numbers, it works like this. The real parts get multiplied together, and from that we subtract the product of the imaginary parts. Because I times I, the imaginary unit, equals -1. So when we multiply the imaginary parts together, we get a real number with a negative sign. And then the imaginary part oh, this doesn't do auto-align. That's a shame. The imaginary part will be the real part of one number times the imaginary part of the other, plus the imaginary part of one number times the real part of the other. Because both of these will be an imaginary number times a real number, which is imaginary. So those end up being the imaginary parts of the new number. Division is also a little tricky. So to help us with that, I'm first going to define a conjugate method. Again, if you're familiar with complex numbers, you already know about complex conjugates. But the complex conjugate is the complex number but the imaginary part takes on a minus sign. And to divide a complex number by another complex number, what we do is return complex number actually, let me think through. How do we do this? I haven't done this in a while. Yes, so the numerator equals, that'll be the complex number self times the conjugate of the other number. The denominator will be the number times its own conjugate. This is now a real number. So we can divide the numerator, both parts, real and imaginary, by this real number to get the result. So this denominator should only have a real part. And I divide both the real and imaginary part of the numerator by the real part of the denominator. Because the denominator doesn't have an imaginary part. And then I also need to implement this modulus, which it tells us about modulus complex number. I forget what it is. Yeah, it's just the norm. So that's the math.square root real part squared plus imaginary part squared. Now we run our code, and we got the wrong answers for some things. Why is that? So the output for our modulus needs to be a complex number as well. So we'll just update that. And now we pass the test cases. We'll now submit our code, and it will run it against even more test cases, and we see they all pass without trouble. So that's just a little demo of how Hackerrank works. An example of writing a class, mostly from scratch, to do some mathematical operations. I'm going to do one more challenge rather quickly on Hackerrank, just to show another challenge. This one also comes with some boilerplate code for handling input and output, which is very convenient. This challenge is a little bit more difficult, I think. The challenge is you're given a certain number of types of coins with different denominations, and you're asked to make change for some amount of money. So we're given 4 coins, an 8-cent piece, a 3-cent piece, a 1-cent piece, and a 2-cent piece, and we're asked to make change for 3 cents. And we could do this 3 different ways. 3 1-cent pieces, a 1-cent piece and a 2-cent piece, or a 3-cent piece. And we're asked to just count the number of ways to make change for 3 units given these coins. So with this problem, what I notice is there's 2 ways I can approach making change here. I could, for instance, deduct 1 cent from this amount using the 1-cent coin, in which case now I'm faced with the problem of making change for 2 cents using the same amount of coins. The other possibility is that I use, say, a 2-cent coin, and I reduce it to 1 unit. Well, now I can't use a 2-cent coin again, because 2 is too big for making... Oh, sorry, let me phrase this differently. So I could subtract 1 cent, and now I have to make change for 2 cents with any of my coins. The other question I could ask is, what are the ways in which I can make change for 3 units without using a 1-cent coin? Well, there's only one way. It's the 3-cent coin. But if I ask myself this question at each stage as I make change, then I'll eventually arrive at the answer. The ways that I definitely know how to make change for is if n is 0, I know that I can make change by doing nothing. If n is less than 0, or I've run out of coins, then I have not found a way to make change. You know, I can't make change without coins, and I can't make change for negative amounts. Otherwise, the ways to make change will be equal to the number of ways to make change for n minus say the first coin in my set using any coin, plus the number of ways I can make change for n without using the first coin. I have to log in. So those of you who are looking closely may recognize this is a recursive function. I get ways, that function calls itself. And furthermore, if you paid attention to the algorithms lecture, you may notice it calls itself twice, which means that we're going to be inefficient and calculating some things more than once. Okay, so no response on standard out. Something did not work correctly here. What are we supposed to output here? Just a number. Okay. String around ways. There we go. So my solution works, but if we submit our code, what we're going to find is because I am using this inefficient recursive method, I'll pass some of the test cases, but other ones are going to time out. They take too long to run. So I need to improve the computational efficiency. I have to improve the time complexity of my algorithm. So instead of using a recursive solution, I might use memoization or dynamic programming like I described in the algorithms notebook. So it's telling me that this test case terminated due to a timeout. I took too long. So hopefully this introduces you to a new tool for testing your programming skills. There's also a discussion board attached to each problem where people talk about how what sorts of problems they encountered or how they solved the problem. Of course, this is people answer this question or these problems using all kinds of different programming languages, so you may find answers for other programming languages other than Python. One thing to watch out for here is at the top of this text box, you can select what language you want to answer the question in. So make sure that you have Python 3 selected in this dropdown before attempting the question. Yeah, I really like Hackerrank. I've spent a lot of time on it, challenging myself with their programming challenges, and I think it's really helped me learn to solve programming problems.